Hello and welcome back. In this section, we'll continue taking questions from the 11 most repeated topics in chemistry UTME. Remember to pause the video, attempt the question before you watch the solution. Question 6. A metallic ion S2 plus with an inert gas structure contains 18 electrons. How many protons are there in this ion? So that means this ion has 18 electrons. And in its neutral state, when it hadn't lost 2 electrons, 2 plus shows that it lost 2 electrons to have 18 electrons. Then in its neutral state, you have 18 electrons plus the 2 electrons it lost, giving you 20 electrons. And of course, the electron number for a neutral state atom is the same thing as the proton number for a neutral state atom. And of course, in chemical reactions, electron participates and you use electrons to write electronic configuration. You use the electron number. So the proton number will always be the same, even if the atom becomes an ion. The only thing that will be affected is the electron number. So the proton number will still be 20 for this ion as it was in its neutral state. Option A. Electron number will only be affected if it is a cation as shown, then electron number will reduce. And if it were an anion, S2 minus, then electron number will increase. It will be 22. You add 2 to the number of electrons in its neutral state. I hope you enjoyed this. Now let's go over to the next question. Some properties of chemical substances are mentioned below. Sour taste, slippery to touch, yields alkaline gas with ammonium salts, has a pH less than 7 and turns phenolphthalein pink. Which of the following are not typical properties of alkalis? Alkalis or bases, for example, we have the sodium hydroxide, the potassium hydroxide, and the rest of them. They have the hydroxyl ion, the OH ion. And some properties, they are slippery to touch, they yield alkaline gas with ammonium salts and turn phenolphthalein pink. But for I and IV, sour taste, this is wrong, and a pH less than 7, wrong. It is only acids that have pH less than 7. And also acids have sour taste. For instance, a substance fermented, it becomes more acidic and tastes sour. So for this, we have option C as our correct answer. Next question. We have a reaction equation, and this question is in accordance with nuclear chemistry. In the reaction, S is, now for us to find the value of S, we are going to have this equation balanced, so we'll be able to find the value of X. Like the normal chemical reaction equation, the nuclear reaction equation should also be balanced. Now let's look at the reactant side. We have the product side here. The reactant side is where this S is, and you can see that we have S as the unknown. So we are going to use the product side to find the reactant side. Now let's look at the mass numbers. For the reactant side, you have 14 plus X, which you do not know, giving you 17 plus 1. We're looking at the mass numbers now. These are the mass numbers. So 17 plus 1 is 18. So that means that the sum of the mass numbers in the reactant side should also be 18, because 18 is the sum of the mass numbers in the product side. So X is simply 18 minus 14, that is 4. So our X is 4. Now let's look at the atomic numbers. We're going to sum 2. We have that 7 plus, let's call it Y, will give us 8 plus 1. And 8 plus 1 is 9. So that means Y is simply 9 minus 7, giving you 2. Okay, we now have the mass number and atomic number of this S. Now, which particle is this? This is what we are focusing on. We have it as 42S. This is a helium atom. Option B. This is because the helium atom has its mass number as 4 and then atomic number as 2. And of course, it is an alpha particle. So it is safe to say that in this nuclear reaction, an alpha particle was involved. So if you're faced with a question like this, try to write out the atomic masses and then the atomic numbers so that you will be able to balance the equation and then be able to deduce the particle in question. Next question. If Y is an oxidizing agent that reacts with a reducing agent Z, which of the following is correct? Now note that oxidizing agents, they are reduced. And when you look at their oxidation number, looking at the number line, their oxidation number is always reduced. This is the number line. The oxidation number will go from a higher number to a lower number. Now, the reducing agent is the opposite of the oxidizing agent. The reducing agent is always oxidized, and its oxidation number goes from a lower number to a higher number. Okay, now the oxidizing agent being reduced means that it actually gains electron. For instance, let's use the reaction between sodium and chlorine to give us sodium chloride. Sodium has its oxidation number. It is written alone, of course, 0, and there is no charge. Chlorine, 0. In sodium chloride, sodium is +1, chlorine is -1. So you can see that the reducing agent here is sodium. It went from 0 to +1. Of course, +1 is larger than 0, so it is the reducing agent. Now, sodium from 0 actually means that it is in its neutral state, electrons are complete. To +1 means that it lost an electron. So that is why you say reducing agents are oxidized, they lose electrons. Now, for the oxidizing agent, they are reduced. Chlorine, from 0 to -1, it actually gained electrons. 0, electrons are complete in its neutral state, then -1, it gained 1 more electron. So our correct answer is option B. Y is chlorine. In this case, it is the oxidizing agent, then it is reduced. Next question. We have a reaction between zinc oxide and carbon 2 oxide to give us zinc and carbon 4 oxide, and we're being asked, in this reaction, zinc has been. Now let's focus on zinc. In zinc oxide, we're going to find the oxidation number of zinc. We're equating to 0, there is no charge. Now, zinc, we don't know that oxygen is -2, then equal to 0. So zinc will simply be +2, -2 crosses over and it becomes +2. Now you have in zinc, in the product side, it is simply 0. So that means zinc had its oxidation number go from +2 to 0. This is to say that zinc has been reduced because it was the oxidizing agent. Oxidizing agent, remember that there is a reduction in its oxidation number, goes from a higher number to a lower number. And of course, it is reduced, it gains electron. From +2, zinc lost 2 electrons, then to 0 means that it has gotten its 2 electrons. I hope that was easy to solve. And I also hope that you enjoyed this section. Okay, now if you'd love to have more access to more UTME past questions with detailed and simplified step-by-step solutions, then you have to get the iClass Simplified UTME video series, where expert tutors provided detailed video solutions to over 600 UTME past questions for each UTME subject. This is a video series that you need to have as someone that is preparing for the UTME, and the most beautiful thing about this video series is that these questions and their solutions have been structured topic by topic according to UTME syllabus. So if you're interested, then call or WhatsApp the numbers shown on the screen to get yours.